1D is looking at a product. So if I can establish the u as being the inside, which is the exponent, the derivative of cosine is negative sine. So this sine of x dx is going to be taken care of with a negative du. Right? So those two pieces are getting replaced with negative du. So just like the previous problem, you've got a negative on the outside. You've got e to the u du. And the integral of e to the u is e to the u. And then you have to go back and plug in that cosine. Forgot that negative. There we go. Get that negative on there. So negative e to the cosine of x plus c. Now let's look at some where the u is not going to be the inside or the exponent part. That's always going to be your first step. You're going to look and see, can I establish u as being the exponent? But in this case, I have two of them. So anytime you have two exponentials, something else is going on. There's going to have to be some sort of manipulation. 1e is tricky to diagnose. But keep in mind that the denominator can be u as long as du is in the numerator. Remember, that is my natural log rule. My natural log rule is du over u. So even though these are equivalent to one another, I've got two terms down here, and two terms down here really throws me off. I say they're equivalent. I just meant that the exponents are the same, but I can't split anything up and simplify it because I have two terms. So this is what the diagnosis should look like. We should be set up as u is equal to e to the x plus 5. It's going to be the whole denominator because du is going to be e to the x dx. So now that part can be replaced with du, and the bottom can just be u. So now we're starting to blend our rules together. That's a natural log integral. And you're going to have to be able to work through all of your rules, not just one or two of them. So the natural log of u would be your result. So then we would take the e to the x plus 5 and plug it in. Now, f looks very similar, but it's actually really different in terms of how we diagnose it. The reason is because I only have one term in the bottom. So again, if I were to establish this as being u, that wouldn't help me because I've got two things being added up here. But what I can do is I can split. I can split this. Technically, you could long divide, but that's really tricky with exponentials. That's not something you're used to doing. But I can split up the numerator. So let's see what that looks like. We're going to rewrite as e to the 7x over e to the 3x. And again, the reason I knew to do that is because I only had one term in the denominator. I had more than one exponential. I had one term in the denominator, so I was trying to simplify this. So I'm going to have that. I'm going to do two completely separate integrals here. E to the x over e to the 3x. Remember, you can split your numerator. These reduce. So your rule is that if you have the same base, you're supposed to subtract your exponents. So that's what I'm going to do. I'm going to subtract. So I've got the integral of e to the 4x. And then if I subtract this correctly, I actually end up with e to the negative 2x. You need to be careful with that. There would have been the 2x in the bottom, but we don't want to work with that as a quotient. We want to make sure we're looking at it as a power. So each of these are a completely separate u sub. This is going to be u is equal to 4x. So du is equal to 4dx. So we're going to need an extra 1/4 to balance that one. And then you're going to have u is equal to negative 2x. Du is equal to negative 2dx. So you're going to need an extra negative 1/2 to balance the second one. So let me go ahead and draw an arrow and an equal sign here. So you are working with the integral of e to the u and another integral of e to the u. Well, those integrals are really easy. They're just e to the u, but you're going to have a 1/4 on this one. So that's going to be e to the 4x. And then you're going to have a negative 1/2. So I could do plus a negative, or I can just do minus, because it would be a negative 1/2 e to the negative 2x. Remember, you don't have to have 2 plus c's. A constant and a constant would add to give you just one constant. So you don't have to have 2 of them. I don't like negative exponents. So we're going to move the negative 2x with the e down into the denominator. So I have something that I feel a little bit more comfortable boxing off.